In this video, we're going to be going over idempotency. We're going to discuss its definition and a real-world example, and then we're going to talk about some engineering examples. One of those, a REST API, and then an infrastructure configuration example. These will demonstrate idempotency as it would apply to development work. Let's first look at the definition. Idempotency means a certain operation can be applied multiple times without changing the result after the first time the operation is applied. So what does this mean? Let's look at a real-world example. So you're going to do some yard work. Let's say you want to mow your lawn. You get your lawnmower out and you set the blades to 4 inches off the ground, and then you go about mowing the lawn. You should have now cut your grass to 4 inches. If you were to immediately mow the lawn again without changing the blade height, you're not going to cut the grass any shorter. And you're not going to magically make the grass 2 inches tall. It wouldn't matter how many times you mow your lawn, you're always going to get the results that you set the blade height to, in this case 4 inches. This is an idempotent operation because each pass has the same result. To change the results, you need to change the operation. It doesn't matter how many times we cut it, it's always going to cut to the height we set it to. That means mowing the lawn is idempotent. Now, you notice a few brown patches and you want to revitalize the lawn. You buy a bag of seeds and you spread 100 of them across your lawn. But what if you repeat this operation? You take 100 more seeds and you spread them around the lawn. You now no longer have 100 seeds in the lawn, but 200. And if you were to do this one more time, you would have 300 seeds. Each pass changes the resulting number of seeds. This operation is not idempotent because each identical pass changes the end result. For a technical example, we have this REST API definition. In this API/animals/dogs, we have 2 items. We have a corgi named Willie, and we have a beagle named Molly. Let's run a get operation against this API to get information on the dog named Willie. This is a basic GET request, and we'll just get back the information requested. We can run this again, and we'll get the same result unless the API information itself changes. This makes a GET operation idempotent, but it's kind of cheating because the GET request by nature isn't changing anything with each operation. It's just gathering information. If we wanted to change something in our application, we can use the put request. In this example, it was our corgi's birthday, and they're now 6 years old. If we wanted to bump the age of our corgi in our application to 6 years old, we can run this put request with our updated block of information for the dog named Willie, and this updates the age of our dog to 6. If we run this put multiple times, and if we don't change the actual data or request, we're always going to set this info of the dog named Willie to the same thing. Once again, it's an idempotent operation. For those of you that have knowledge of RESTful APIs, we also have the post request. I'm not going to get into the specifics of the differences, there's other resources for that. But let's have a post example in our context. We're adding a new dog named Try. Now we run this request, it's going to add this dog to our list of dogs in our application. Now our application has 3 dogs, Willie, Molly, and Try. But the post operation is not idempotent. It's just inserting the item into the application, it does not check if it already exists. So now if we run it again, we're going to have 4 dogs. And 2 of them are going to have the same name, Try, with the same information. So again, it's not idempotent because every time we run it, it's changing the results. For infrastructure, here we have some rough AWS Terraform code. Terraform is an infrastructure configuration tool used to define a given infrastructure to be built. Terraform is often cited when talking about infrastructure as code. Here we have a snippet of 3 EC2 instances and 1 attached load balancer. If we run this, we would get this infrastructure in the cloud. That would be 1 load balancer, and 3 instances set up in our AWS account. Terraform has this concept of a state file. Every time you run Terraform, it's going to take the current state that's created and save that in a file. What this gives us is a reference for Terraform to check every time you run the code, to see if the action's already been completed. This process makes Terraform idempotent. Because it's idempotent, running it again, Terraform is going to check the code against the state file to see if anything has changed. It's going to see we already have this configuration, it's not going to change anything. This is the same thing for every subsequent run. Why does it need to be idempotent? Why can't we just write our code and run it? Well, what if we wanted to make changes to our configuration down the road? Terraform has this idea of setting the desired state in code. This is very common in a lot of different infrastructure tools. This means that the code you're writing should be by definition the exact layout of the infrastructure you want. In our case, we may want to change our infrastructure in the future by, say, adding 5 instances instead of 3. We should be able to update our code and run this Terraform again, and it just updates our infrastructure instead of creating a whole new parallel stack. Hopefully that's enough examples on what idempotency is and how it's used in dev and operational contexts. Feel free to let me know if you have any questions.